Hello, and I want to welcome you to a discussion on quadratic functions. So let's get started. Here is some basic terminology in theory on quadratic functions and the graph they make called parabolas. So I'm just rearranging the screen for me to be able to use my software. So looking at this bowl shape here is called quadratic, and it can either be the shape that it is now, or on the other side can be upside down. So in the center of this parabola you can see you have an axis of symmetry where x equals h. Into the function we have h, and then we can make k our vertex, or the point of where we have the lowest point or the highest point. Highest, that's the maximum. Lowest, there's a minimum. Okay, you have a minimum when the parabola opens upward, and you have a minimum when it opens downward. You'll learn more about that later. So in particular we have f of x equals ax squared plus bx plus c. And then you have what this video is going to be focused on in standard form. F of x equals a times quantity x minus h squared plus k. So let's get started. Remember, a cannot be 0 because that would make this a linear function where we're looking at quadratics. So with this we're asked to determine the coordinate pairs of the vertex of these. Now this is very easy to do whenever you have a parabola in standard form, because h is right here and k is right there. And what you can do is say that h keeps the same sign, so we're going to keep the negative 4, comma, and then the k as the same sign, comma, 9. And remember, h has the opposite, and that was a negative 4, so we're going to have a positive. So we have a positive 4, comma, 9 as a coordinate pair. For number 2, let's keep in mind that here is h, and here is k. Knowing that h, we're going to have a 5, now we have to think about the sign, it's positive, so as opposite we're going to have a negative, comma, and then just the regular k, keeps the sign. And that makes the coordinate pair. Okay, looking at graphing one of these, this is the procedure. We have f of x equals x plus 3 squared minus 2. So we have to first determine the vertex using h and k. Remember, h is going to be 3, but we have to change the sign to be negative, and the vortex, and the y component of the vertex is going to be just the negative 2. So I would go ahead and plot that negative 3, comma 2 right there. Okay, we change colors. Okay, now what I want to do is find the y-intercept. And that just means let x equal 0. So when we do that, we're going to say f of 0 equals, open parentheses, 0 and for x plus 3 squared minus 2. Okay, continuing on this thought, we have 0 plus 3 is just 3, and we're going to square that, minus 2. So we have 3 squared is 9, minus 2. We're going to get 7. So we're going to have the x-intercept of 0, comma 7. So let's plot that. It's going to be right here. And something to keep in mind is that our line of symmetry is going to follow where that red dot is going to be that same vertical line. So there's our line of symmetry. And now we can actually connect in a U shape, our red dot and our blue dot. And now, since this is our line of symmetry, how many points we are from this area is how many we're going to be on this side of the row. So 1, 2, 3. Let's go 1, 2, 3 in the other direction. There's another point. So now let's connect that to make a U shape. And that is our parabola. Now the domain is going to go forever in the negative infinity, and it's going to go forever in the positive infinity. The range is going to be bracketed, our x component of the vertex, comma, positive infinity, and then let's have parentheses. And finally, our axis of symmetry would be x equals, and then just the x component of the vertex, or x equals -3.